Hi everybody. Today we are talking about reduced row echelon matrices, sometimes also called Hermite matrices. Be careful, they are not just row echelon matrices. There is an important difference. We discussed row echelon matrices in the previous video. You will find the link in the description below. They are called reduced row echelon because, as we will see, they are a particular case of row echelon. Here in the picture, we see how a reduced row echelon matrix looks like. Here, the red stars mean that you can replace each of them by any arbitrary number. Besides those stars, all the other numbers are either 0 or 1. And this is the main difference between reduced row echelon and row echelon. So let's define them. We can summarize the properties of a reduced row echelon matrix in 4 very simple steps. First, we draw our stairs, like we did last time for row echelon matrices. Now, the first property is just a reminder that those matrices are actually row echelon. We said it's a particular case. So in particular, they are row echelon. However, now every element in the corner should be equal to 1. And also, every element lying above each of these corners is necessarily equal to 0. And all the other elements, here denoted by a red star, can be arbitrary, as we already said. That means that any number is allowed, 0 or different from 0. It doesn't matter. And here we have the 4 properties altogether. Now let's see some examples. The first is a 5 times 7 matrix. Again, we are drawing our stairs. And we clearly notice that we have 4 corners equal to 1, this, the second one, third, and fourth. And above each corner, all the elements are equal to 0, as you can see in the picture. And finally, under the stair step, all the elements are equal to 0 as well, while all the other elements are arbitrary. Here we have the red elements 3, minus 2, 2, minus 1, 0, and 6. They can be any number. As for the second example, we have a 3 times 4 matrix. Let me just draw the stairs like before. So we have 3 corners which are equal to 1. Below the stair step, we only have zeros. And above each corner, we only have zeros like before. And all the other numbers, here the red numbers, are arbitrary. That means that they can be either equal to 0 or different from 0. It doesn't matter. Now, remember that in the previous video, where we talked about row echelon matrices, not reduced, we showed that both upper triangular and diagonal matrices are actually row echelon. However, here things are a bit different. First, we notice that in general, an upper triangular matrix cannot be reduced row echelon. For example, because corners need not be equal to 1. As we see here, our corners are 8, 1, 2, and 1. Some are equal to 1, others are not. So no, in general, it's not a reduced row echelon. For the same reason, it is clear that even diagonal matrices in general may not be reduced row echelon. Because here again, we have some corners which are different from 1. However, there are some diagonal matrices which are reduced row echelon. The only ones are the identity matrices. You probably remember the definition of identity matrix. If not, don't worry, because you will find in the description below a link to our video where we define shortly identity matrices in detail. So yes, identity matrices are reduced row echelon. But that's it for today. Please stay tuned. I'll see you in the next video. Thank you very much for watching. Please don't forget to like, comment, and subscribe. Thank you very much again. Bye.